Hello, this is Brenda Wingard-Haynes, and this is Biochem 208, and we are progressing along in Unit 6. We have concluded discussing primary, secondary, tertiary, and quaternary structure, and have now moved on to protein denaturing and hydrolysis. So we're going to switch gears a little bit and talk about proteins that we only consume in the diet because we're trying to narrow our focus. And so if we consume protein in our diet, those proteins must be dismantled into amino acids. Once we have an amino acid pool, we will take those proteins and reassemble them into the contractile proteins, structural proteins, collagens, immunoglobulins, receptor proteins, enzymes, polypeptide hormones, all those sorts of things that we need in our body. Now, denaturing will disrupt the bonds that hold those attractions together. So since it's hydrogen bonds that hold secondary structure together, if we denature hydrogen bonds or disrupt hydrogen bonds, we will disrupt secondary and tertiary structure and so forth. Okay? Now, outside the body, we want to utilize the idea of denaturing proteins to render bacterial proteins useless. We are on a constant battle against bacterial proteins. And so one of the ways of doing that is by using heat. And you can use heat in cooking or sterilizing surgical instruments. And so again, the types of proteins we're targeting here are bacterial proteins. So in this picture in your lecture notes, what you're going to see is that the heat is going to disrupt the attractions that hold this protein together, say in this area, and will basically denature the protein that you're trying to render useless. Okay, so that's a very effective way of doing that. An example might be a raw egg, and we heat it up, and you get your cooked egg. That gives you a real good visual on protein denaturing. Okay. Other ways of denaturing certain proteins are with acids and bases. And you can do this, for example, if you're interested in certain food products like yogurt or cheese. Okay, now the reason that your yogurt or cheese will curdle or glob up is because your bacterial protein is putting out lactic acid. Okay, so lactic acid. Remember, acids are proton donors. Okay, so when you get that lactic acid, that is also going to disrupt and denature those forces that hold the secondary and tertiary structure into place. Okay, so this is how we get the milk to coagulate in yogurt, or if we take it a little bit further, how we make our cheeses. Okay, on the next page in your lecture notes, organic compounds can also denature, and they're useful for what we call disinfecting. Okay, so if we draw, for example, isopropanol or isopropyl alcohol or rubbing alcohol, okay, partial positive, partial negative, and we bring it in the vicinity, say, of an amino acid with a hydrophilic functional group, partial positive, partial negative, what we end up getting is an attraction that we didn't have before. So it's kind of like having, say, a rubber band that you are stretching in a direction that you wouldn't normally have. Okay, so the useful part of alcohol in denaturing bacterial proteins is the hydrophilic OH group that will also hydrogen bond to other certain amino acids. Okay, and again, the reason this might be useful is that you want to render this protein useless or incapacitated at the very least. Other denaturants are heavy metals. So heavy metals are things like lead, lead-4, chromium-6, mercury, another form of mercury, etc. Silver is one. And so my question here is, what do metals form in general? What I'm meaning here is they form positive ions. Okay, and so what that means is that if you bring a positive ion in the vicinity of an amino acid that isn't supposed to have a plus, you could also stretch and distort the amino acid chain just like you did up here. Okay, so the positive part of the heavy metal will disrupt the negative parts of the amino acid. Okay. So again, the normal attractions of the R group are disrupted and we get denaturing. Okay, now denaturing isn't always terrible. It's certainly terrible if you've got bacteria. And so an example of this is the use of silver nitrate, which forms silver ion and nitrate ion in solution. And silver very readily precipitates, meaning we form an aqueous plus an aqueous yields a solid. Okay, it's got this plus charge. It's going to attract these negative R groups. It very easily precipitates, and therefore silver nitrate drops are used in the eyes of newborns to kill bacteria that would present itself in the birth process. Okay, so as you see in this picture, the silver nitrate drops in the eyes of this newborn would have killed this bacteria that you're seeing over here. Most of the time when we think of heavy metal denaturing, though, we think about it as being poisonous. An example of this is mercury. Okay, so you can see in this picture that clearly this individual has been incapacitated in a major way. Mercury poisoning leads to birth defects, brain damage, weakening of immune systems, and many, many, many severe problems. Okay, and what you need to recognize about mercury is that it's highly associated with the burning of coal. Okay, when you burn coal, you release mercury into the atmosphere. It falls back to Earth in the form of water, contaminates the water, and enters the food chain. Okay, and what we need to say in our country, you know, this isn't Japan, but we burn coal for electricity. And so every time we have our cell phones charging, our computers on, our TVs on, our light bulbs on, our refrigerators on, all of those items, we are largely burning coal to do that. So remember, there's no free lunch. And when we're running electricity all the time, we are releasing coal into the atmosphere, which releases mercury into the atmosphere, which comes back to Earth and contaminates water, which contaminates everything. So my rhetorical question here is, what do you think this has to do with you personally? I would say turn your lights off, turn your computer off, turn your cell phone off, and use electricity judiciously. Okay, the last thing I'm going to talk about on this particular audio file video part of the lecture is pink disease. And you can see from the picture here that pink disease literally turns the extremities, hands and feet, pink. And if you read the discussion on this, what this is saying is that mercury used to be used in baby products. Now, we in this country would never think about putting mercury into our baby products, but it certainly used to be used and may still be in place in other countries.